All right, letter K. Let's look at K. Huh? Yeah, I understand. A, B, C, D, E, F, G, H, I, J. J was the homework, right? J was homework?
Yes, sir.
Evens?
Yes, sir. No homework.
Question on J.
That's why they have the golden hours.
Questions on J.
12.
You didn't even do it.
I sort of did. You did not did it.
Questions on the homework.
Six. Number 6.
6? You got it.
Yes.
All right, 6. All right, problem number 6. So we have f of x is equal to 2x squared minus x over okay. They just want to know, let's see, for the rational function, identify the location of the whole as an ordered pair. Okay, so we need to factor top and bottom. Agreed?
Yeah, you can take 2x out of the top.
Close.
I mean 2. Yeah, x.
X, okay. So that's 2x minus 1. And then the denominator, I'd say, is going to be 2x and x.
Minus 4, plus 1.
Minus 1, plus 1. Is that right? Does that look like it's factored about right? So we have a shared binomial on top and bottom, agreed? So these produce our whole. Okay? They will not produce a vertical asymptote. So solve 2x minus 1 for 0. So x equals half. So at half comma something, so I'm going to use what's left to figure out where the whole exists. Okay. Oh, our favorite complex fraction, J. So we get 1/2 over 1/2 plus 1. 1/2 plus 1 is 3/2, I believe. Multiply by the reciprocal, so 1/2 times 2/3. So at 1/2 comma 1/3, we have a whole. So a little secret about these, and I know you guys are excited about this. If I had graphed this and I had graphed this, both graphs look identical. Okay? The one on top would have a hole at 1/2 comma 1/3. Okay, but the graphs would look the same if you had graphed them. And again, Desmos doesn't always show a hole. Sometimes your calculator will show a hole, but it just becomes you being able to identify. So our quiz on Friday, there's 2 parts. There are 4 questions that ask you to graph it, and I want you to be able to graph it by hand. You can do it. I'm not looking for artistic ability. I just need you to do the best you can. Okay, I know you can do it. And then the other part is all multiple choice, and you get to use either a Chromebook from Desmos or graphing calculator. Yeah.
So Mike, can you do
Chromebook just to look up the answers?
Yep.
Can you do 4?
4? Yeah.
Seriously?
Can you do 2 after 4?
Sure.
No.
Number 4. F of x is equal to x squared plus 2x. Minus 24. X squared minus 3x. Minus 4. All right, we want to go ahead and factor top and bottom. So I say top would factor x plus 6 and x minus 4. Now I'm thinking one of those binomials will be on the bottom. X minus 4 and x plus 1. Okay, so the x minus 4s are shared between the top and the bottom. So set x minus 4 equal to 0. X equals 4. So at 4 comma something. So we're going to take what I have left and plug 4 into that. Because if you plug 4 into the original, you'll actually get an undefined term. So that's going to give me 10 over 5. So at 4 comma 2, we would have a hole. And number 2 was also asked for. Number 2, f of x is equal to x squared minus 4 over x squared plus 5x plus 6. The top is difference of 2 squares, so x plus 2x minus 2. And I bet you one of those is going to be a factor of the bottom, and lo and behold, yes it is. So at x plus 2 equals 0, solve it. So at negative 2 comma something. So plug negative 2 into that, so negative 2 minus 2, that's 0 over 1. So at negative 2 comma 0, we would have a hole. What else from the homework would you like to see?
Do 8.
12.
Doing 8. Flipping the page finally. I guess there was no more evens. 8. Now we want to graph it. All right. All right. Math, graph, Cartesian. Great. So we get f of x is equal to x squared minus 4 and 2x squared minus 4x. Let's go ahead and factor it. Okay. So b and I share the x minus 2 at 2 comma something. That's going to be 4 over 4. So 2 comma 1. So at 2 comma 1, I have a hole. Can anyone see that I put a hole there? It's like, no, it's a circle with them. It is a circle. That's representing our hole. And then let's see what else we want to do. A vertical asymptote. So whatever is left in the denominator. So that's going to give me x equals 0. So here's this asymptote. And then we want horizontal asymptote. Set the top, let's see, the degree on top and the degree on bottom, so y equals half. Good. The reason it's half is because that lead coefficient is 1, so 1 over 2. So y equals half. It's going to be a squeeze on this one. Something going on in there. All right. And x-intercept. It is, yes, thank you. Undo. Can't take me anywhere these days. That makes me feel better, and that makes it easier to graph from my part. All right, and then we want x-intercept. So whatever we have left on top, so that's going to give me negative 2. So negative 2 comma 0. And then y-intercept. So I'm going to plug 0 in. I could plug 0 into either. So that's going to give me, this gives me 0 over 0, which is undefined. So it's undefined. So what can you tell me about the y-intercept? It doesn't exist. It's an asymptote right now. So we have the whole. Oh, we can take care of the domain as well. So the domain will go from negative infinity to 0, 0 to infinity. Best stuff ever.
Yeah, I already took pictures of them, so you're good.
Cool. Yep. All right. So I would say this is going to look something like this. Something like that. And then something like that. And can you see how the whole it sits there? And if I had graphed what I had left, x minus 2, if I had graphed this part, if I had just graphed this over this, it would actually do that. So if you graph the thing without the hole, it doesn't have a hole in it. Which, duh, if it doesn't have a hole. Okay. All right, any other last minute questions? Time for maybe one more.
12.
Sam wants 12, even though I didn't do it. All right. f of x equals x squared plus 6x minus 7, or x squared plus 8x plus 7. So let's factor it. Top's going to factor to x plus 7, x minus 1. Does that seem okay? And bottom's going to factor to x plus 7, x plus 1. So I'd say this is going to give us our whole. So at negative 7 comma something, so we'll go negative 7 minus 1, that's negative 8 over negative 6. So that's 4 over 3. So at negative 7, we gotta go bigger on this one. That one. At negative 7 and at 4/3, which is about here, we have a whole. Okay. Let's see what else we can play on here. We want a horizontal asymptote. So the degree on top is equal to degree on bottom. Lead coefficients are 1. So y equals 1. Is that right? Mm-hmm. Okay, so that's going to come along here. Vertical asymptote, I went out of order on these, sorry about that. Vertical asymptote.
It's negative 1.
What do you think?
I think it's negative 1 because it's x plus 1 on the bottom.
Yeah, negative 1, thank you. So x equals negative 1. Cool. And what else we got?
The x-intercept, so you plug 0 in.
Yeah. X-intercept goes in for the numerator, this one, so at 1 comma 0. So this graph is going to look like this.
Okay, cool.
Fancy dancy. All right.
So once you find the hole there and you're trying to find the other things, can you just like ignore that part when you're plugging in other numbers?
I would say yeah, except for probably the horizontal asymptote. You just wanted to, just in case you don't want something to fall out.
Oh yeah, sounds good.
I think what you're saying might work, but I would hate for, like, let's say your factors are like 2x plus 1, and that was the one that canceled out. You would have needed that 2 on the x to do it. So that's the only, but I might be wrong.
Okay, sounds good.
All right, we good? Pass them up, please. A whole bunch of people on phones, good to know. You guys have some group chat with each other.
Well, that's just because I just do the homework.
Look at Sturp's bald spot.
I would never do such a thing.
It's okay, Pete. I know it's there.
Oh my bad, sir.
One of these days, I'm just gonna pull the trigger and say, boom, I'm shaving it. I'll put my left earring back in, put a hoop in.
That'd be so funny.
You know, the last time I had that earring in was 7th grade. Left ear. Everyone's like, dude, check out her earring. So I found a not paper clip, but a safety pin on the bathroom floor of the boys' locker room. Ran it under some warm water. Then shoved it on through. You should have seen what that left lobe looked like after about a week and a half. I had to go to the doctor. The doctor said, well,
do it again, Stirrup.
Let's clip it out. Well, find me one on the bathroom floor. I'll do it again.
Yeah. What? I've had multiple people tell me I look
It's the
good.
You would.
All my missing work just is going in tomorrow.
Oh, you're just telling lies.
No. Dude, whoever drew this is funny. But they said not.
Bit bay. All right. So we have had quite the adventure with this chapter. This is actually the last part, and then tomorrow's review, and then we will have Thursday's a review, and then Friday we will do our test. There's 2 parts to the test. One part you have to do without a calculator. Sure, you can use a 4 function. You can even use scientific on that one, but you can't use the graphing And I think you can do it by hand. And again, I'm not looking for you to be the most wonderful artist and generator.
Which one?
Huh?
On Friday?
Yeah. So there's one section, there's 4 questions. They're all graphing.
Oh, okay.
And I don't have one where you have like that middle region where it's at like 2,740.
So the graphing ones are close like the beginning of the unit.
Well, graphing is what I'm doing up here each and every time.
The ones where you graph it by hand, I'm saying like.
But I bet you'll have one that'll just be, well, you'll have 2 vertical asymptotes, so you have this and then that and then that. So I would bet you'd have this for one of your graphs. So however that might be, so you'd have 2 vertical asymptotes in there. I bet you'd have one like this. And then I bet you would have one that would be like that, but with a hole in it.
So you're not gonna have one of those funky ones.
And then we'll actually have one that looks like this, where you have it graphed. And this is your end behavior asymptotes, something like that, which you'll see today. All right, so we have dealt with vertical asymptotes, horizontal asymptotes.
Diagonal asymptote.
Today is the diagonal, which is called the oblique, or the end behavior. So,
Oblique and muscle.
oblique, yeah. All right, so we need to consider the last situation, okay? So, remember when we have the top larger than the bottom, we don't have a horizontal asymptote, okay? But you have an end behavior asymptote, so you have to think about this. As I plug numbers going to the right, so starting from 0, as I plug numbers in, what grows faster, the top or the bottom? Does it grow faster if I square something and add 3 or just subtract 5?
Top.
So the top. So the top grows faster, so this will grow faster than the bottom. So as that, then that means the function at x is going to approach infinity on this one. Same thing on this one. The top's going to grow faster. Same answer. Okay? Okay, does that make sense? They will both get to infinity, but one of them is going to be larger numbers faster than the other one. So the top will work faster than the other. So if the degree of p at x on the top is greater than the degree of q of x, which is on the bottom, then there's no horizontal asymptote. Instead, there's a slant asymptote. The slant asymptote is a divided by c, where a is the function on top, c is on bottom. So we're going to have to go back to the long division to deal with the end behavior. Okay, the end behavior will be a graph. A lot of times they'll say it's just a line. It can only be linear. That's not correct. It can be anything. It can be quadratic. It can be a 3rd degree, 4th degree, 5th degree. It's just what you're doing is you're looking at what, as I go to infinity to the right and to the left, does my graph start approaching? Okay? So there's not too much on these to work on. So let's see. Determine if there's a horizontal or a slant asymptote. So this would be a horizontal, okay, because the degree on top is a 1. This would be a slant because the top degree is more than the bottom degree. This would be a horizontal because the degrees are on top is less than degree on bottom. And this would be also a horizontal. So there's only one slant up here, okay? And again, the slant can be called oblique. It can be called end behavior or slant. They're all going to be the same type of terminology. And it really just depends upon what you're doing. Hey, he's here.
Get a haircut? Did you get a haircut? Oh, not bad.
I don't know.
All right, so first thing I want us to do is let's go ahead and divide. So we're going to bring back an old friend. We're not going to do this as synthetic. We're going to do it as the old school. Okay, so if I divide this, remember I'm going to go, because I have 2 terms, I start here, 2 terms over. Still with me? What times x gives me x squared? X. Okay, so I go x times x is x squared. X times negative 3x is negative 3x. Okay, I'm subtracting both of these. So make that a plus, make that a minus, make that a plus. So if I do that, I don't get anything here. I get negative 2x plus 4 because I have to bring that down. Is that okay so far? Next question, I don't worry about the 0. I worry about the negative 2x. What times x gives me negative 2x? Negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Again, we're subtracting them. So if I subtract them, change that to plus, change that to plus, change that to a minus. So then I get negative 2. I'm not worried about the remainder on this. So this right here, y equals x minus 2 is my end behavior asymptote. So if I had graphed this, and you'll see in a little bit, if I had graphed this, if you also had graphed on top of your graph x minus 2, as all the wiggles and stuff get done and you go to the left and to the right, it's going to follow along that same linear equation for the end behavior. Okay? So same thing with this one. X plus 4 into 2x squared plus 9x minus 5. Again, I have two terms. So I'm going to start here. Okay, what times x gives me 2x squared? And that should be 2x, I think. 2x times 2x is 2x squared. 2x times 4 is 8x. Again, I'm subtracting these. So if I subtract them, change that to plus, change that to minus, minus. Those cancel. That gives me 0. That gives me x, positive x minus 5. What times x gives me x? Well, that would be positive 1. Positive 1 times that is x. Positive 1 times 4 is positive 4. Again, I'm subtracting these, so make sure that's plus, minus, and minus. So I get negative 9. Again, my remainder doesn't make a difference. So on this, my slant or my oblique or my end behavior asymptote, that's what it would, the line it would follow along. Seem good so far?
Yep.
Yes. All right. Can I move on? Cool. All right. So as x approaches infinity, what will happen to the remainder of the division problem? Goes away. Okay. The remainder, when you divide it, we ignore it because it goes away. It approaches 0 when you get there, so we don't have to worry about it. So to find the equation for the slant asymptote, you use long division. To find the equation, the remainder is not part of the equation. Okay? All right, so taking a look at this. Do I have a vertical asymptote? Can I figure out? Yeah, so my vertical is x equals negative 4. Okay, vertical here. Looks like that. Okay. I don't have a horizontal, right? So during the test, it's going to ask you the same thing. I might say circle one or the other. Okay, it doesn't have a horizontal asymptote because the degree on top is greater than the degree on bottom. So, nope. Okay, some of you are right. D and E does not exist. I don't care. I know. And then the slant asymptote, I'm going to use long division. See if I can squeeze it here. X plus 4 into x squared minus 2x minus 3. 2 terms over. That's an x. X times x. X squared plus 4x. We're subtracting, so those cancel. That gives me negative 6x minus 3. That's a negative 6. So negative 6x minus 24. And if I subtract those, I get positive 21. Again, I don't worry about the 21. Okay, so my slant asymptote is y equals x minus 6. Okay, so let's graph the end behavior asymptote. Let's use green. That's a fun one. All right. Do we know how to graph the linear equation?
Yeah.
I hope so. It has a y-intercept of negative 6. Goes up 1, right 1. Up 1, right 1. Remember this? So that's my end behavior asymptote.
Oh, so they're just like simple line stuff.
Yeah. Nice thing is in here, we're just going to deal with them being lines, but they can be parabolas, they can be thirds, they can be fourths, but we're just going to deal with the lines now. Okay. So that green line is what as I go to the right and to the left, is the asymptote that my graph is going to approach. All right, back here.
Dotted line as well, then.
Well, I just made it neon, but yes, dotted is totally fine. I made it neon because I had fun colors. Roots. It looks like I can take my denominator, set it equal to 0. So I'm going to get negative 4 comma 0 because that's what my denominator equals 0 is. So negative 4, 0. Did I get that right? Let's see. Yep. Right there. Oh, wait. Why did I do that?
Because you're silly.
Sometimes, let's see, let's factor the top. The top factors to x minus 3 and x plus 1. I meant to do the top. So I have roots at 3 comma 0
And negative 1.
and negative 1 comma 0. I know you guys wouldn't have let me get too much further on that. So I have
When
that.
you're in roots, you plug in 0 for y, right? So since there's no k, the bottom disappears. It's just the top. Cool.
And then the y-intercept, plug 0 into our equation. So I'm going to get negative 3 over 4. So add 0, comma negative 3 over 4. 0, negative 3/4. Somewhere in there. So this is kind of do this. This is going to come down, dip down below. Bless you.
Bless you.
Blessing you still. It's going to do that. And then this side is going to do this. Notice how as I go to the right, it approaches the green. As I go to the left, it also approaches the green. That's it. That's what it looks like. Okay. Pretty cool. So fancy. I like that green. That's a good solid green color.
So you're only gonna have like the 3 different asymptotes when you have like x squared and all that stuff on the bottom, right?
You can have vertical all day long. You can have multiple vertical all day long.
Yeah.
You can have horizontal with vertical, but you can't have horizontal and slant.
Okay.
So, because the degree on top is more than the degree on bottom, it no longer has the horizontal asymptote.
So good.
Can I move on? Life happy? Yeah. All right. Vertical asymptote. Vertical asymptote. X equals negative 3. Everyone feel comfortable how we found that? Even those on the phones?
Yep.
Okay. All right. Horizontal asymptote. Yes or no?
No.
No. Why not?
Degree on top.
Because it's bigger on
Yep.
top.
So the degree on top is more than the degree on bottom. So nope, that doesn't work. Slant asymptote, yep, sure does. So I'm going to take the bottom, x plus 3, and I'm going to go into negative x squared. Now this is kind of weird because I only have one term under here.
Are you gonna
So
have like an I?
I'm not going to deal with any i's on these. All right, so ready? What do I have to multiply times x to get to negative x squared?
Negative x.
Negative x. So negative x times x, negative x squared, minus 3x, bless you. Okay, if I subtract that, that becomes plus, so that's gone. That becomes 3x. And then I guess I could say, what do I have to multiply times x to get to 3? That would be positive 3. So I get 3x plus 9. If I subtract these, I'm going to just get this negative 9. I ignore the negative 9. So my slant asymptote is y equals negative x plus 3. And I think I remember how to graph linear equations, at least this week. All right, so I got a positive 3. It's got a negative 1 slope, right? So I'm going to go down 1, right 1. So this is my slant asymptote. Cool? All right, roots. What makes the top 0? Well, 0, 0 is going to work real nicely for our roots because I solve that for what makes that 0? Well, 0. So there's one root. Good. Y-intercept. If I plug 0 in for my x's, I'm going to get 0, 0. So that's my y-intercept as well. And this graph will probably do something like this. Something like that. And then this does something like that. And it's done. Okay. Could this point go up higher than this? Yeah, this graph could be this. Could be something like that. I don't know. I mean, if you get the blue, you nailed the concept. Okay, I don't want you to go plug in additional points going, look, Mr. Sturb, I got 5/16.
So for our test, we allowed to use Are there calculators like to graph this or no?
So there's there's graphing on the two different sections. The one section, the bigger of the sections, you can use the Desmos or you can use a graphing calculator, your choice. The other part, you can just use a scientific calculator.
Okay.
Because I want you to be able to do it by hand. But again, I'm looking for, when I'm graphing these, I'm looking for, did you get the asymptotes and did you get the basic idea of what the graph looks like?
Okay.
I'm not looking for, oh no, it came up a little extra than that, -1.
Okay.
Unless it's Hannah's, but
So like you.
just because I know Hannah would start crying if I. Right.
What
What you
about-
reading?
Oh, well.
A book.
What about that problem we had a couple days ago where the one thing was like really low down and you couldn't see?
I don't think we're gonna see that on the today's or on the test.
Okay, so
I'm not gonna throw something like that at you like that. That usually happens when your two vertical asymptotes are really close together. That's when it usually will happen. I'm not gonna throw something like that at you.
Okay.
But if it happens to show up, we'll just say, hey, you know what? Skip this problem.
Nice. Skip all the problems.
They all must do that. All right. Vertical asymptote, -5. X equals -5. Horizontal asymptote?
No,
No, why not?
because it's bigger.
Because bigger on
Yeah,
top.
bigger on top, so nope. I think nope is an official math term. Slant asymptote, sure. So I'm going to go x plus 5 into, just to make this easier, I would flip-flop it. Plus, yeah, that's exactly right. All right, so what do you have to multiply times x to get -5x squared? That's -5x. So I get -5x squared. And then I get -25x. If I subtract these, those cancel out. -25x comes down. And then plus 45. Come on, squeeze in that 45. And then what do I have to multiply times x to get -25x? And that's going to be -25. And that's just downright nasty. Man, I'll tell you. Let's see, can I adjust that one? Oh, I can.
Couldn't you?
I can adjust it. Do you guys have the same capability as me?
No. Always goes down to -10.
Yeah. Find your way.
No.
Oh, jeez. Now I have to erase this one because that's now off. All right, so here's this asymptote. Sorry you guys didn't have this real cool feature on yours, but let's see. +45, got there. And I'm going to go down 5, right 1. Down 5, right 1. Like here. So this is kind of that. And notice I counted by 5s on each the x and y. Go to pen. Roots. Can I solve the top for 0? So I'm going to get -45 equals -5x squared. So x squared equals 9. What's the best error people make when they take the square root of both sides? They forget some pivotal thing? Yeah?
Not to that, but I think you did some math wrong. 45 minus 25 is not 25 is positive.
Oh, but that's -25x. So, it should be positive, right?
Yeah.
Oh, okay. That's
Still
still
got
positive 25, so that's going to give me a
Massive line.
positive 25. That's positive 25, right? Oh my gosh. Just can't take me anywhere these days. I can adjust my graph again. I'm sorry. It's like, Mr. Sharp, we don't have these cool features on our paper. It just doesn't work the same. I don't know. So I want positive 25. That'll work. All right. So vertical asymptote -5. So it's here. Slant asymptote is at positive 25. So 5 right there. And down 5. So 1. So down 5. So down here, right. 1. There it is. Okay. Roots. So as I'm on the roots, what's the answer? If I have 9 equals x squared, I take the square root of both sides. Do I get 1 or 2 roots? Come on, what'd you always forget to put in on algebra 1? And then you always got to take plus minus, thank you. So plus or minus 3. So I have 3 comma 0 and negative 3 comma 0. So 3 comma 0 is like about right there. And negative 3 comma 0 is like right in there. Y-intercept, oh, y-intercept plug 0 in for x. So I'm going to get 45 over 5, so 0 comma 9. Oh, this is a pretty graph. I'm so proud of myself. All right, so this is going to do this. And what's going to do on the other side? Oh.
Man, that graph is
Our graph isn't big enough to actually see. So there's something else that takes place up here where this and this intersect. It's like up in this region. Sorry, I didn't make it nice enough. I'll give you guys extra credit if you make your graph work. Really? All this extra credit. Hey, I got done. Holy cow. All right. So what was that? What did we just do?
section 11K.
Okay. You guys want evens again?
Yeah.
11K evens?
Odd.
I'll do evens.
On the test, you should have it in front of the test, just do even.
You got it. If you do evens, you get half of them.
That's assuming you get them all right.
Oh, is that what the graph? Okay, thanks for finding what the rest of the graph looks like.
11I, J.
Is that full credit right there on the test?
Full credit.